Hi everyone, this is Dr. Bass. I'd like to talk about an abbreviated truth table problem from the 7.4c, number 14. Take a look at this. This is the problem, and as always, with an abbreviated truth table, the idea is to try to fill in a row of the truth table in such a way that you can show that it's possible for all the premises to be true and the conclusion to be false. In order to do this, you start off by filling in, marking the conclusion as false, and each of the three premises in this case as true. First premise marked true there, second premise there, and the third premise there. Now, if we want the conclusion to be false, then how is that possible? This is a conditional. How can a conditional be false? There's only one way. Namely, it has to have a true antecedent. The antecedent here is you. And it has to have a false consequent. That's this not, M or N. So, we want to make sure that the antecedent is true, the consequent false. And of course, if not M or N is false, then that tells us that M or N inside that has to be true. And you may look and say, well, there's something more to it, because you've got to figure out what values M or N can have, and it looks like there's different ways that could work. Well, there are. However, in this case, it's going to turn out to be easy. There are three different ways that a disjunction, like M or N, can be true. It can be true if they're both true, if M and N are both true. It can be true if M is true and N is false. And it can be true if M is false while N is true. The only way that the disjunction is not going to be true is if M and N are both false. Just to have something to put in here, let's just assume that they're both true. That is, we'll assume that M is true, and we'll assume that N is true. And we mark those. And when we've got that much, we've got the beginnings of solving some of the rest of the problem. For example, one thing that we can solve immediately is we say, oh, we found out that U has to be true. And we've got a U down here. So we're going to put the T under the U. We've got this useful phrase, this not M or N. And we see that actually we could look at this and say, well, there's M or N here and not M or N here. But M or N has these three truth values. It's true, true, true. And so we can put it over here. M, true, true, true. Likewise over here. True, true, true. And here in this third premise, we've got a not, a tilde in front of it, just like in the conclusion. So we can mark that one as false also. What else can we do? Well, let's take a look around. In this third premise, we've got if not S, then not M or N. We know that not M or N has to be false. We've got the false under the tilde here for that. We've got a T under the arrow because we're trying to make the premise true. How can you have a false consequent, like not M or N, and a true conditional? Well, there's only one way. You have to have a false antecedent also. If false, then false is true. And so you want this not S to be false. And that tells you that you put an F under the tilde and a T under the S. And when you've got that, well, you've got another premise done, and you've also got an answer to something from the first premise. You know now that you have not S is a false true, and so when it shows up as the consequent in the first premise, that's got to be false true also. By the way, you just saw me move the things back to pull it into alignment. That's for your benefit. Putting it in alignment is to make it easier for you to follow. It doesn't matter as far as Logic Tutor is concerned. Logic Tutor does not care how well lined up it is under the symbols and letters. If you have the right symbols or the right truth values in the correct order, then Logic Tutor will say fine. It doesn't matter how neat it is. Now, we've gotten a good ways. Now we're only working on this first premise. We've got X and N. If X and N, then not S. We already know that N is going to be true. Now, we've got a false consequent. Here, not S. And we've got a true conditional. This is the same problem that we had to solve before. So how is that possible? Only if you've got a false antecedent. That means that X and N, the whole thing, has to be false. But you know that N is true. So how can X and N be false? Well, it can be false if X is false. And if we have every single truth value on the right side of this filled in. Everything fits, everything makes sense, everything is consistent. So let's start putting them in here. And we have X is false, we have N is true, we have S is true, we have U, that's also true, and we have M is true. In other words, it's false, true, 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 true. Let's see what we've got. If we've done this right, got a bunch of true conditions, 3 different ones, and a false conclusion, so that should be invalid. Let's take a look and see if we've got it. And we've got it. We have succeeded. Congratulate yourselves. That's the correct answer.